So here is your final tune-up for the 1-1-1-3 quiz here. I'm giving you the function f of x that looks like this. It's a semicircle. Still frozen? I'm giving you f of x, which is a semicircle, and I'm showing you what g of x in red here is. The g of x is the transformed graph of f of x. So what you're to do is to come up with the equation of g of x. And what we want to do, of course, is try and identify, and this is the big deal right here, try and identify a, b, h, and k, and then we're going to put those values into this format right here. Okay, so we're going to identify those. So the first thing you want to do is try and identify the stretches in the vertical and horizontal and or the reflections. Okay, you want to identify those first, and then we'll identify any translations, moves left or right or up or down. So we take a look at the blue graph, f of x, and I notice that the overall width is 8 units. Everyone see that? 8 units. What's the overall width? And I guess I'm starting with b here, not a. I'm starting with b. That's just what I looked at first, I guess. What's the overall width of the transformed graph, taking in the two corresponding sets of points? Is it the same? Okay, so it kind of looks like b has not, it looks like b is 1. Okay? Now we can change this as we go through, but it looks like b is 1. That it hasn't, now has it been reflected? Okay, so now b, let's see, b is in with the x there, so that's going to flip the x's. So does it look like it's flipped this way? Well, it's tough for us to tell, isn't it? Because it's very symmetrical. So we can say, yeah, maybe that's flipped, but it's flipped onto itself. So, I mean, really? To be honest with you, I would accept probably both a positive one and a negative one here, because look at this blue graph. If you flipped it, because it's symmetrical, it would map onto itself. So we'll probably just go simple when we can and just say, you know what, b is probably 1. So let's take a look at a now. A is this stretch, right? And what you want to do, again, is take the overall sort of height or whatever, the overall max to min of the original graph, and then compare the max to the min of the transformed graph. And obviously we do have a reflection, don't we? A reflection this way. So that means all the y values have been multiplied by -1. So a should be negative, okay, because it does flip this way for sure, because this is opening, downward, this is opening upward, so that's a flip. And what is a then? Well, we've got an overall sort of max to min of 4 units, and then in this new one, it goes from 10 to -2. So that looks like 12. Is that correct? 12 units? Okay. So 4 compared to 12, what's the factor there? Times 3. Okay? So a is 3. If it's been stretched by a factor of 3, then a is 3. If it's compressed by a factor of 3, that's b is 3. Remember, it's opposite for b. A is... Okay, so this is what we got so far. Now, the tricky part here is trying to figure out the translation. If you go from this point to this point, you may be in some trouble, because remember, this has been stretched, right? And it's been distorted, really. So you have to be careful. Now, what you want to do is you want to think through these points right here, the x-intercepts on the original graph. Okay, we haven't moved them in or out, right? The b is the same. And they haven't been moved away from the x-axis, because this a value, okay, when this flips, that doesn't change. When this stretches, this doesn't change, right? Because a times 0 is still 0. So these would be, for the two stretches, those are invariant points for the first 2 steps. Does that make sense? So we have this, it's flipped, and then it's stretched, right? Roughly. So these points have stayed the same. So a good idea would be to go, hey, I know that I can just map this point. I can find out how to get to this point, because those correspond. All right? And you'd be in a little bit of trouble if you went from, hey, this is like a vertex down here to a vertex down here, right? So you got to think through that part to get the h and the k proper. Does that make sense? Think through the stages of transformations. That's why we do a and b first. So, okay, so I'm gonna use this one. So we have to go from -4. We have to go over to +4. So that's an h value of 8 units. Is that correct? You guys with me there? So h would be +8. It's going to show up as a -8 in our equation. Is that good? Okay with that? And then we have to go from here then, we go over 8 and we have to go up how many units? From 0 to 10? Does it look like 10? Are we in agreement with 10 or is that good? What do you think? 10? Okay. All right. So what is the final graph here, or the equation of the final graph should look something like this. And I'm going to use red. Oh, did I do K? What? Oh, I erased it accidentally. So the A value is -3. The B value is just 1. The H value is 8. So it's going to be x minus 8 to move it to the right. And then plus 10. Is that what you're telling me? Did anybody else have this? Yes? No? Okay. Let's look at my solution that I have over here. Does this look? It's pretty good to me. All right? That's what I did before, so that looks pretty good. Any disagreement with that or any confusion with that? Yes? Why is A negative? Okay. So A, remember A is a vertical stretch, so it pulls this way, but it also can flip the graph this way. So all of these, like this A value right here, or sorry, this Y value is +4. We see by the orientation of this graph that it has been flipped vertically. You see it's opening down, and then now it's flipped to opening up. So that means a negative A value. Yeah. If the whole orientation of the item, whatever it is, oh, scissors, that's a good one. Okay, so let's say the graph was like this, and then if the transformed graph looks like this, that's a negative A. Whoa, watch this. This is really good graphics. If the transformed function looks like this, that's a negative B. Right? Isn't that amazing? Or the hand, right? Here's the thumb. So if the transform function looks like this, that's a negative B. If the transform function looks like this, that's a negative A. And if you need some dance moves, that's all you got to do. You just got to do the rotation, like this. Just put it all together, right? We could probably have a demonstration later. No? Okay. Anyways, just saying if you're stuck. Good question. Yes. Why is K 10? Okay. Why is K 10? All right, just one more explanation here. Why is K 10? K is the vertical movement, right? So you can look at it two ways. What I did was I took this point, okay, and just envisioning that this gets flipped with a negative A, it also gets stretched with a negative 3A. So this point stays the same, so does this one, because it's on the x-axis. So that's a good point after those stretches have been made to say, okay, where is the corresponding point on the new graph? And for this one, it's right here. You see, we've got this. So I need to move this point over a certain number of units. And then from here, on the x-axis, how many units up do I have to go to get this new one? And we have to go from 0 to 10. That's why K is 10. You could do it from here. You could go from the vertex way down here. See? If you know where this vertex is, so we've got, this is 4, going to flip to -4. What's -4 times 3 is -12. So this is actually -12. You could go from this vertex up to this vertex, which is at -2. So -12 up to -2 is 10 units. So you just follow that, do the stretches, and then pick a point and figure out where the corresponding point is, and that'll help with translations. Any more questions? All right.